databases, where an individual database breaks is not a fixed number. It depends on how the database is being used. The main problem with relational databases is that you're effectively limited to one server. And you have the option, of course, to scale up that server larger and larger in a vertical capacity. But at a certain point, you have to do sort of creative destruction in order to take it further. You can shard the database, which virtually every large company does, but there's a whole bunch of trade-offs involved in doing that, and a lot of maintenance, a lot of systems work involved. The promise of NoSQL is that a lot of this stuff can be automated and much easier to maintain and available to a much broader class of companies, which in turn opens up a whole new world of what's possible in their applications, things they might not have thought about before. So there are many different types of databases. So beyond the classic relational database, about 10 or 15 years ago, the big talk was in object databases. And then with the reemergence of NoSQL databases, this notion has been transformed a bit. And so we generally hear about 4 types of databases. Column stores, things like Cassandra or HBase. We hear about document databases like MongoDB. We hear about key value stores like Couchbase or Aerospike. We hear about graph databases like Neo4j or Titan. The CAP theorem essentially states that in a database you have to choose between consistency, availability, and partition tolerance, and that you may choose 2 of the 3, but you can't have all 3 together. What does this mean in practice for NoSQL databases? It means you have to choose between consistency and availability. It means you have to choose between consistency and availability, because any cluster has partitions in it. Now, this question is actually more complicated than that, because availability in terms of the CAP theorem is more of an academic construct, when what you care about fundamentally is whether your application can reach the cluster and what it can do. Also, all of these databases can live in multiple places on that consistency availability spectrum. So I tend to say that it's a good place to start, but it's not the only way to evaluate where you want to be. And that's why I like to prefer the term sort of speed versus reliability, because I think that makes more sense from an application and business perspective than the CAP theorem. I believe that column family databases, document databases, key value stores are all converging around a kind of distributed key value storage platform, with more and more features being layered on top. I think what we're going to see really exciting and interesting progress is along where they take this underlying facilities and the different kinds of features they layer on top. For example, right now, using each of these databases requires a certain amount of domain expertise. You really have to design your application to be aware of the underlying platform you're using. I see different vendors doing things like layering SQL support on top of their key value platform. That's an incredibly powerful idea. Now, there's no such thing as a free lunch in a distributed system, so in doing so, there's going to be things that those are better at and things that those are worse at. But I think you're going to see a lot of interesting progress in terms of how consistency is achieved, in terms of how people are able to get ACID transaction semantics on top of it, and how people are able to make the development process easier in these databases. Now, I would like to separate, even though the column family, document, and key value store databases are converging in many ways, this is just a subset of NoSQL databases. This is a subset I like to think of as operational data. These tend to be applications that need to handle a high amount of load, which generally means a large number of transactions, but relatively simple transactions. There's another whole piece of that whole big data space, and that's doing this analytic workload, things where Hadoop traditionally comes in, and being able to run queries across these massive databases is an area that's just beginning to emerge. And I think there's going to be a lot of very interesting progress there as people do refinements to MapReduce, various flavors of real-time MapReduce, and so forth. We see MongoDB used a lot for real-time analytics because it's very, very simple to get data in and very simple to query across a cluster through that. We've also used Cassandra for real-time analytics. With Cassandra, you have to spend perhaps more care up front modeling your data in the way you want to bring it out, but it's an extremely powerful platform for getting data in and out quickly.